Last week, we've learned how to perform definite integration. And we know that definite integration is one method that we use to compute or calculate for the area under the curve or bounded by the function to the x-axis. For today, we're going to be working on the same concept, but this time it's going to be a little bit more exciting because we're going to be using multiple functions in our integration. So for this particular problem, you need to modify the function before you integrate this because you cannot do product rule in integration. So you have the upper and the lower. This will turn into x to the 6th plus 3x to the 4th minus x squared. And you're evaluating, or this is the derivative function, that's why you have a dx. And we're going to integrate it from -3 to 3. So we'll have x to the 7/7 plus 3x to the 5/5 minus x to the 3/3 evaluated from -3 up until 3. So you will have two functions. One would be 1/7 subtract it, and you'll have your answer. And since I always showed you how to use technology, let's just compute this using Math 9. So I'm going to cheat a little bit because I don't want to perform all these crazy values, but if you have a calculator, you may do so. So Math 9, -3 up until 3 of the function, I'll use the simplified version, which is x to the 6th. And I'll have 898 point something, which is our value. 898,457. Let's write it down. 898.457. 898.457 unit square or square unit. Why do we put the square unit? Because we know every time we use the definite integration, we are basically calculating the area under this function, this polynomial function. So we did problem number 1, we evaluated it, we simplified the f of x, and then we just want to check if it's an even or an odd number. We know it's an even number, and by evaluating the integral, using some of the properties, 898.457, 898.457. So using one of the many important applications of the definite integration. So let's say I'm going to illustrate to you a function. The first curve or first function is given by this graph right here. We call it f of x. We don't know if that f of x is a secant function, a tangent function, or a polynomial function. It's just that that is the graph of that f of x. And we have another function in our graph, and the graph is this graph. We call it g of x. So we have f of x on top, g of x on top. And let's say I want to compute for the area between f of x and g of x bounded by a and b. And our a and b are our x coordinates. So x is equal to a and x is equal to b. And we're going to find the area between those two curves. So how are we going to use calculus to find the area between the two curves? We're going to use the formula. And the formula that we're going to be using, I'm going to use the technical way of how we write this formula, which is to find the area between curves. We're going to use the integral between the area is equal to the integral between a and b. A is the lower limit and b is the upper limit between the top function f of x minus the bottom function g of x. And we know that this are two derivative functions. So this is the formula that we're going to be using in finding the value of the area between the two functions And to make it more descriptive, the area is going to be the low and the high of top minus bottom function. So this is how we're going to be using our formula in finding the area between two functions under the two intervals A and B. So that is how we're going to be computing for this problem. We're going to find the area between the two graphs, f of x and g of x, between 0 and 1. So if we're going to use our formula, we're going to be computing for the area. So the formula is low minus, or low over high, of top function minus bottom function. Now between f of x and g of x, and without seeing the curve or the graph, how are we going to verify which function is the top function and which one is the bottom function? We're not going to be able to just guess and pick, oh, it's f of x, because according to the formula, it's f of x minus g of x. So technically, we'll just use x squared minus 1 minus x and we're done. No, that's not how it works. So you need to make sure that you are understanding which one, if you see it in the graph, which one is the top function and which one is the bottom function. So there are two ways. One, we can graph it using a graphing calculator. But if we don't have the graphing calculator, we're going to find the height. So to check which one is top and which one is the bottom, we have f of x and we have g of x. So let's pick a value. Let's say 1, f of 1. So if x is equal to 1, what is the value of the height of the function? And if g is equal to 1, what is the height of the function? So if one is on top of the other or higher than the other, that is the top function. So f of 1 is 1 squared plus 2. G of 1 is 1 minus 1. So we have 1 plus 3. So y is equal to 4 for problem number, for f of x. And for g of x, 1 minus 1 is equal to 0. The height of our g of x is 0. So which one is higher? Obviously, it's this function. So this is now a verified function that is on top of our function. Now, how are we going to use the second method? If you know how to graph a function, we know that x squared plus 2 is a parabola opening upwards with a y-intercept at y equal to 2. So up. And we know that 1 minus x, it is a function that is going downwards because it has a negative slope. So at 1, there. That is the function that we are looking at, and it's at 0. And let's say 1 is maybe here. We don't know if it's the intersection. So that is the area that we are trying to solve. So let's solve it. So we're not going to use the calculator yet. We're going to be using our calculus skill. So we know that the range is at 0 and 1. F of x minus g of x, or top minus bottom. So this is our top and this is our bottom. So we have x squared plus 2 minus 1 minus x. And we know that we're going to integrate it. So we're going to find its antiderivative, but we're not going to do that yet. We're going to do a little bit of algebra. X cubed all over 3 plus x squared all over 2 plus 1x. Evaluated from 0 up until 1. So now that we have our integral functions, we're going to evaluate it from 0 to 1. So we'll have the upper minus lower. So 1/3 plus 1/2 plus 1 minus 0 over 3 plus 0 over 2 plus 0 times x. So we know this is going to turn to 0. So area is equal to 1/3 plus 1/2 plus 1. I'll just use the calculator then. 1 divided by 3 plus 1 divided by 2 plus 1. Math, fraction, let's see if it's going to give us a fraction. 11/6. Right. So that is how easy and simple finding the area of this function. Easy, right? Make sure that every time you are working in any calculus problem, you need to visualize the function you're working on so that you will have an idea which one is the top function, which one is the bottom function, and what is your lower limit and what is your upper limit. Otherwise, you're going to have difficulty working on this, because today we're going to learn how to solve functions like this by hand and using technology. It can be your graphing calculator or some app that we're going to be using in a little while. Okay, next challenge. On your own, can you please compute for the area between the two functions that you're seeing right now, between -2 and 1? Again, the area from -2 up until 1, top is 5 minus x squared. Obviously, x minus 1 is the bottom. I'm going to simplify, and I'll have 5 minus x squared minus x plus 1 dx, and I'll have area here is 99/6 unit square, or square unit. Lisa is 33/2. 33/2 units squared. This is Hayden, and this is Alyssa. Any other answer? Parabola going downwards, which is f of x, and a linear function that is going up because x is positive, and we have the top minus bottom. And we need to find that area using f of x minus g of x, and evaluating it, we'll have a value that should be 99/6 or 33/2 or 27/2. Which one is the right answer? 16.5. No one is right. What is 16.5? 99 divided by 6. 99 divided by 6 is 16.5. 33 divided by 2 is 16.5. Know your math. All right. Since we're here right now, let's take a look at this example right here. Look at example number 2 and problem number 1 and number 2. What do you think is missing in the information that we have on problem number 1 before we can solve it? If you are going to evaluate this. So Avner says problem 1 has no bounds, and that is also correct. So how are we going to rectify this issue so we can solve for the graphs of the two functions? So does that mean that we're not going to be able to find the area between curves because we have a missing information? Of course not. If this is algebra, probably, but this is not algebra, this is calculus. So we need to do more. So the next thing that we're going to do is to find that, or those range of values for our limit of integration. Word for the day, limit of integration. So how are we going to find the limit of integration? What mathematical procedure are we going to do to be able to compute for the points of intersection of f of x and g of x? According to Avner, set f of x equal to g of x. And that is correct. You set f of x equal to g of x because that's the mathematical way or notation to compute for the solutions of our function. So f of x is equal to g of x. So this is the technical term. 5 minus x squared equal to x minus 1. Okay. But before you can factor this out, we know that in factoring, we need to make sure that the quadratic term or the leading term is positive. So we're going to set the negative aside and focus on x squared plus x minus 6 equals to 0. So is this a factorable quadratic equation? Yes, because the middle term is positive. So plus 3 minus 2. So the solutions, x negative 3 and x 2. And now we have all the ingredients we need to find our area between curves. Minus x plus 6. Don't forget the x. 20.833. 20.833. Now, what about if you don't have the graphing calculator? Okay, for alternative, we'll use technology, online technology. So let's find an app that will help us work on our homework tonight. Yeah, you can use Wolfram as well. I think Wolfram is similar to this one. So, is 125 divided by 6 equal to 20.833? 125 divided by 6. It's the same thing. All right, guys. So, use your graphing calculator, TI-84, or use this app to be able to find your area under the curve. Or you didn't able to find the answer at all.
I'm still working on mine.
Joey's still working. Who's typing? What are you guys typing? Well, I cannot see it right now because I'm on the presentation screen, so I can see it. I can see the chat box. So if you have an answer, just yell it out. Michael?
I got 11 halves.
11 over 2?
Yeah, I didn't feel like putting it.
No, it's okay. 11 over 2. Any other answer? Oh, because you still figured out which one is the top function and which one is the bottom function. So now that you know which one is top and which one is the bottom, which is f of x and g of x, you'll have this integral. Do you have this integral? If your integral function is 2x cubed minus x from 1 to 2, then that means you're on the right direction. I'm not sure if it's the right answer, but at least you know you're in the right direction. And excuse me, from here, use technology. You can use your calculator, or you can use your app to be able to find the area under the curve. According to Michael, it's 11 over 2. Did you say 11 over 2?
Yeah.
Huh? 11 over 2, 6. You miss 1. So there's a little bit of value.
Minus wrong.
Yes, but close. 11 over 2. Okay, close. 5.5. But it's 6 units squared. And that is the answer that I am wanting to get from you. Are you looking at the screen?
Yes.
Thank you. Can you please just speak because I cannot see the chat box. All right. So Joey is seeing it, so I'm guessing all of you are seeing it. Good. Now, if we're going to compute for the area between the two curves, can you please tell me the issue that you're going to have if you're going to answer this type of problem? Give me one.
You got a square root.
You have a square root, and when you have a square root, it's a difficult problem to solve by hand?
Yes.
And Joey has a point, and I would agree. All right, so provided that we're going to be using technology to be computing for the computation of the area between these two curves, what else do you need to find to solve for the area between the two functions?
The limit.
Limit of integration. Michael is correct. Now, if we're going to find the limit of integration for these two functions, how are we going to execute that? According to Michael, we need to find the solutions or the points of intersection of the function. So we have y. How are we going to find the solutions of this function using algebra? We can solve this, of course we can, but it's going to be tedious and we might end up with fractions and decimal. So we're going to be using technology, okay? So aside from the fact that we can use technology to compute for the definite integrals, we can also use technology so we can find the points of intersection of the two functions. Are you ready to learn something new today? All right, so this is Desmos. So Desmos will help us find the solutions or the points of intersection of f of x and g of x. So we're going to type in our first function here. It doesn't matter which one. Just type in whatever function we have, x over generated.
Yes.
Good. Now, we don't even need to do algebra. We don't even need to use calculus. All we need to do is to hover our cursor, and click on the point of intersection. And those are the coordinate of that point of intersection. We have x and y. So which one are we going to be using? Obviously, the x function, because this is the x coordinate. So this is 1.1808, and this is 0.763. We don't care about the y right now. We only care about the limit of integration with respect to x. So write that down. I will write it down. We have 1.1808, solution 1.1808, and the other solution is, do you think the other solution is just 0? Yeah, it is 0. So it's just 0, so x is equal to 0. So now, how are we going to construct our limit of integration? Because we're not going to be able to use the calculator if our function is wrong. So the limit of integration would be, is the upper limit. So now that we have our limit of integration, dx, because that's the derivative function, now you're ready to compute for the area under the curve. Can you please use your technology? Non-calculator, use your app. Go to Wolfram or this app right here that I just used, which is the same as Wolfram. Or use your calculator, graphing calculator. Boom, 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 boom. There. The value is 0.785, 0.785, 0.785. David does, huh? So that is how we use the integral function in calculating for problems similar to this one. Now, for your challenge, one of the AP calculus questions, and you know your calculus if you can answer this. Now, look at the diagram. This problem, you need to calculate for the area of the shaded region. And we have three functions. We have this function, that function, that function. Tell me your game plan.
When you just look for P and Q, where the points intersect, so you would only, shoot, maybe that's not, hold on.
Well, yeah, I guess you're right. You are going to be looking for the points of intersection of those 3 points. You're seeing 3 points of intersection. The P, the Q, and the one close to 0, 0. But we don't know if it's 0, 0, so don't assume that it's 0, 0. You need to use decimals to find all those points of intersection. Once you have found the points of intersection, how are you going to be using the formula of top minus bottom? Look at the function. What is the problem, or what will be your issue if you're going to be using the concept of top minus bottom in this particular figure? Tell me.
You can't set them to each other.
Why not?
Well, would you want to set the y equals 4 over x squared to x minus 1 over 4 x squared?
Yes and no.
No.
Well, yes and no, because to be able to use the formula that I showed you, you need to produce 2 integral functions. So you need to do 2 area or 2 sets of areas in your function and add them up afterwards. You're going to find the area to the left and area to the right from the center. I know probably to some of you I'm not making sense, so I'm going to draw it. The point of intersection to 1, point of intersection 2, and probably this one, right? Now, if we're going to use the formula for the area, which is the integral of a to b of top minus bottom, look at this. From here up until here, The top function is with this f of x. Let's call it, let's number it. 1, 2, 3. So we're seeing three functions, right? Look at the first top minus bottom representation. From here to here, the top function is 2 and the bottom function is 3, right? What about if I do it from here to here? Is my top function still going to be the same as my top function on the purple line?
No.
Yes or no?
No.
No. That's why you need to partition it here. So you're going to have two integral functions of top minus bottom. So you have area 1, which is equal to the integral of this point up until this point. So we don't know that yet. We don't know that yet. We don't know that yet, right? So let's say A, B, and C. So from A up until B, your function is going to be top 1 minus bottom 3. And area 2 is going to be from B all the way to C, of top 2 minus bottom 3. You find its area, you find its area, you add them together, A1 plus A2 equal to the right answer. Do you see my game plan? This is like a crazy basketball game.
Yes.
And we're fighting the Martians to win. Are you gonna win?
Yeah.
Yeah. All right, 10 minutes. Okay, so the first thing that I'm gonna do is to find my points of intersection. So I'm going to use Desmos. Where's my other line? Did you have the same problem as, oh, it's right, oh, it's right here. See that? That is the actual graph of the function. That's why I'm not seeing it. Okay, so now that I have this, I need my point of intersection. Did you get the same points of intersection? Yes or no?
Yes.
All right. So my A, B, and C is going to be, my A is going to be 0. My B is going to be the middle, 1. And my C is going to be the last one, which is 2. A is 0, B is 1, and C is 2. So if I'm going to execute our game plan, my A sub 1, area 1 is going to be A through B, because this is A is 0, B is 1, and C is 2. So 0 up until 1 of top minus bottom, which is 1 and 3. What is 1? 1 and 3. So I'm going to go back to my Desmos to verify which one is 1. This one is 1, black 1, x times x plus 3 minus the bottom, which is blue, x minus x squared all over 4. 1/4 x squared is the same as x squared all over 4, okay? And that will be my first area. And my second area is going to be from B up until C, and B is 1, and C is 2. And my top function on the second area is red, which is 4 over x squared, 4 over x squared, minus blue, which is this, x minus x squared all over 4. And after I have my visual right here, that's why calculus, it's going to be difficult if you are not visualizing what you're working on, but once you have the visuals, ugh, too loud. you'll have a better way on how to use technology for your answer. So I'll use my calculator now to find my individual areas. Did you get 17 over 12? Yes or no?
Yes.
Yes.
Did you use technology?
No, I just use my head.
I did.
And see what happened? So are we going to trust your head?
Yeah.
Yeah. Okay, so 17 over 12 plus 13
Just
over
have to
12.
verify it next time.
What is 17 plus 13?
30.
Are you sure?
Yeah.
30 over 12 or 2.5. 2.5 unit squared. Or
I was
square
off
unit.
by a point. That's bull.
What is your final answer?
30 over 12 simplifies really quickly to about 5 over 2.
I got
5 over 2.
29 over 12. I'm off, man.
But if you change it into decimal, what did you get?
2.5.
2.5, right? So, ladies and gentlemen, the area of this little graph right here is 2.5 unit square or squared unit, however you want to say it. And if you're able to answer this, you'll be able to answer the homework that I'm going to give you today. Happy?
Oh God.
I'm so happy. I'm pretty sure all of you are happy too. Okay? So that's it for today. Thank you guys for coming. Be good. Be
Thank you.
nice. Don't be a bully. Be nice to other people, okay? Bye-bye.